Have you ever wondered what really separates a good scientific theory from a truly revolutionary one? You know, the kind that changes everything? Well, it gets right to the heart of how we discover truth. And let me tell you, the answer is probably not what you're thinking. So let's just ask it straight up. What makes a scientific theory great? I mean, if you had to guess, you'd probably say something like, it has a high probability of being correct, right? It just feels like common sense. The best theory is the one that's most likely to be true. But what if I told you the exact opposite is true? The real secret sauce, the thing that actually drives massive scientific breakthroughs, isn't about having a high probability of being right. It's all about taking a high risk of being wrong. And that is the wild paradox we are going to unpack today. Okay, so this brings us to our first big idea, the probability paradox. And trust me, this concept is going to flip your whole understanding of what makes science, well, science, completely on its head. You see, if the goal of science isn't just to be right all the time, then what is it? Well, it's about creating statements that say something really meaningful and specific about the world. Statements that are packed with rich informational content. So how in the world do we measure that meaningfulness? Well, we do it with a concept called empirical content. I want you to think of this as the real engine, the horsepower of a powerful theory. And this is where it gets really cool. A theory's empirical content isn't measured by what it allows to happen, but by what it forbids. The more things a theory says can't happen, the more it's actually telling us about reality. I mean, think about it. A theory that allows for literally everything to happen tells you absolutely nothing. So how do you crank that empirical content up to the max? It really boils down to two key ingredients. First, you need high universality, meaning your theory should apply to as many things as possible. And second, you need high precision. The claim you're making has to be incredibly specific, really restrictive. Basically, you want to make a bold, precise claim about a huge range of things. Now, this all leads to a pretty surprising conclusion. If your theory is super broad and super precise, it forbids a ton of stuff. And if it forbids a ton of stuff, it actually becomes much, much easier to prove wrong. And that, right there, is exactly why science loves improbable ideas. Just look at this relationship. It's a total trade-off. A theory that has a high logical probability, one that feels really safe and likely, is actually going to have very low empirical content. So to get that rich, juicy information about the world, you have to accept a low logical probability. You got to make a risky bet. Let's think about a tautology for a second. Like saying, tomorrow it will either rain or it will not rain. The logical probability of that statement is 100%. It absolutely cannot be false. But what has it told you about the weather tomorrow? Exactly nothing. It has zero empirical content. You get maximum probability, but zero information. All right, let's make this super concrete with a classic example from the history of astronomy. Let's say our first hypothesis is this. All planetary orbits are circles. It's a beautiful, simple, and incredibly precise claim. Now, let's compare that to a second hypothesis. All planetary orbits are ellipses. And it's super important to remember here that a circle is just one very special type of ellipse. So this second statement is actually broader. It's less restrictive than our first one. And here it is. Here's the punchline. The all orbits are circles hypothesis is way simpler and more precise. Because it's so incredibly restrictive, its logical probability of being true from the start is actually lower. It's a much riskier bet than the ellipses theory. But that's its strength. That high precision makes it far, far more testable. Because it's a riskier prediction, it's actually a scientifically more valuable hypothesis. Okay, so what happens when one of these really improbable high-risk theories gets thrown into the ring, put to the test, and it doesn't fail? That's when we reach the ultimate goal. That's when we get something called corroboration. See, corroboration isn't just about finding a piece of evidence that agrees with your idea. It's a measure of its resilience. How tough were the tests you threw at it? How hard did you try to break it? A theory only becomes highly corroborated after it survives severe, relentless attempts to prove it's false. And this just brings everything into focus, doesn't it? The real goal of science isn't to find the most probable theory. It's to find the theory that can be the most corroborated. And that amazing potential for corroboration comes directly from how risky and testable it was in the first place. I absolutely love this quote from the source material. It just perfectly captures the spirit of the whole thing. A great theory isn't something you protect and coddle. It's something you throw into the arena and force to endure the fiercest struggle for survival. The ones that walk out of that fight are the ones that are truly worthy. So let's pull all these threads together. When you get right down to it, the scientific method is all about making a bold bet. It's a strategic gamble, but on a very specific kind of idea. So, a really powerful theory, a game-changing one, has these three core features. It has incredibly high empirical content, which means it's highly testable and risks a lot. Because of that, it has a low initial logical probability. It's unlikely from the get-go. And its ultimate value comes from its potential for high corroboration, its amazing ability to withstand every attempt to knock it down. And that really is the big takeaway here. Progress in science isn't made by carefully stacking up a pile of safe, probable little truths. No, it's made by proposing bold, beautiful, and incredibly risky ideas, and then trying with every tool we have to prove them wrong. The ones that survive are the ones that change the world. And that leaves us with one last thought to chew on. This whole principle of valuing high-risk, precise claims over safe, vague ones is just so powerful. So think about it. Where else in your life, maybe in business or art, or even just in your own personal growth, could making a bolder, more specific, and riskier bet lead to a much, much bigger breakthrough?